is your friend Mainak from Civil Center, and a very happy Sunday to all of you. Welcome to our channel, and today Sunday special one building design G plus 4 in the Tekla Structural Designer software. So we are going to consider certain practical things which we consider during our making a particular drawing, that is roughly. So if you have not subscribed to our channel yet, do subscribe and keep learning. So these are the specifications of the building. We are basically going for G plus 4, floor to floor height of 3.05, and WC blocks are going to be used. So right now we just create some construction levels. So basic foundation level, let's give this minus 1.2 meters, and then the level above it, let's do this as SSL, and the spacing will do this 3.2 meters. Slab thickness will do at 100, and then this is G basically, and we have to go, okay, let's give the spacing of 10 feet, so that will be 3.05, and we'll go G plus 4, so this is G, and 1 2 3 4, so this is the G plus 4 we are talking about, and then okay. And then after that we are going to create import the DXF file of the ground floor first. So the ground floor DXF we are importing here. I want only the center line, I don't want anything else. And then we are doing import this as an and bilayer. So we are going to do this in this plinth level and the particular base level, and then click on finish. And after that we are going to see escape and then import DXF. Once again the same file will import, and but this time we'll import except the center line, everything else will import. Unit is the same in and finish. Zoom in using the mouse scroll button, and then check. So this is the structure which we are looking at. So first of all, now what we can do here is we can make the basic particular ground floor plan first. So for that, let's go for the columns basically. So columns, will first go with the column size of, here we'll go with a column size of 250 into 300, and okay. Steel we are going to give as FE 500, and then this particular automatic alignment we're going to turn it off, and then save this 250 cross, or rather we want this as 300 cross 250. We're going to save this, okay. And now here also we'll change this. This will be rather 300 cross 250 for now, and then okay. And we are going to, as you can see, we are going to apply this. We can also save this in this here, okay. 300 cross 250, okay. Let's just do this, okay. Now we'll just place this in the positions which we want. As you can see in the DXF file, we had already defined the column position, so it's easier for us to actually place the columns like this. So you should check whether in all positions you have provided the columns or not. And after that we'll go for the beams, and for the beams we'll take a size of 250 cross 300, and M20 concrete, FE 500 steel, and then okay, we have missed one column actually here. We'll just save this 250 cross 300 so that we can use it later. One column we have missed, and here Okay, we've given it, and then you can check in the 3D view, all the columns are ready. And now going to the beams, you take the beam which we have created, and now let's assign the beams. So since this is the plinth level, so here all the beams will be, this beam will be joined, this one will be joined, this one will be joined, we'll have this one, and we'll join this one, and let's join all the main beams. Let's join this main beam also. Check the validation. We have some intersection problem. Let's solve that. So grid line is not aligned, so we can take that error. So the model has been completed. Let's take this. As you can see here, the model has been completed for this. So now let's just go to the next floor, to the structure and levels, and go into the next floor. Here now let's import DXF. First floor grid lines we want right now, and center line let's import first, because we want the grid lines and then next, and we'll kind of import it in all the levels here by layer and finish. And then we'll see that, as you can see, the first floor grid lines are imported, and again you can just import the first floor shadows. So just don't want the center line, we want shadow, that the unit is and then finish. Zoom in. Now we'll go only for the primary beams. Later we can do the remaining beams, or even the extensions here. So we'll take the beams here, and we'll go for this particular beam which we have made, and we'll kind of join them all. Okay, if this doesn't work, then we will go one by one. This line, if this also doesn't work, we'll just take this and then take this. Like this we can do. And if when there will be any particular error, we'll just solve this particular error we are having. Okay, just check this, and take the beams again, side of the beam which we want to go with, and then the center point. All these are primary beams. And after that, this one. Single click and then double click. So if we check this in the 3D view, and then we'll insert some slabs on it as per, apart from the staircase position, we'll just assign some slabs to it. And after that, the structure, as you can see, it's ready. We'll go to model and construction levels, and now we can just make this source as 1. All the source will give as 1. Then OK, and after that we'll go back to construction levels and make them back as unique. This step is very important. And after that we'll go to the base level and apply our dead loads first. We're applying loads as per the IS code, so the 11 kilonewton load of the external wall we're going to apply here along all the external walls which we are having. And for the internal walls, the 5.5, apart from the staircase where we'll have the default load of 11. And here it is the tilt level, so we don't have any load here. And next we'll go, you can also check this from here, dead load. Next we'll go to the next level. Let's apply this here. Let's go and apply imposed load first. Imposed loads, level load for the residential building, 2 kilonewton per meter square. Load is applied, and after that let's take the dead load, and then we'll just go with full UDL. Let's apply the load for the external walls first, and we'll go around the boundary first. And also the staircase. You must always check whether there is any multiple point of load application in any case, so that I avoid any position where you apply multiple loads. So we'll apply the staircase first, then start with this one. And after that we'll go with the load for the next beams. So in 3D we will check the imposed loads and the dead loads have been applied. Now we can simply go to the model, construction levels. Apart from the top level, we'll do all this source as 1. Because the top level of the terrace, it will be loading will be different. This is done. Construction levels. Make all this source as unique once again. Click on OK and then check whether all sources are unique. Okay. Now we'll go back to the top level, structure 5, and here let's start with the imposed load first. Imposed load, level load 2 kilonewton per meter square, and then go to the dead load, full UDL 11 for the staircase, and then 2.5 for the parapet wall. So like this we are giving the load here, and if you check the structure 3D, the loading has been done. So now what we can do, we can just go to model, and then we're going to apply some wall panels. double click on the last point, single click on this corner, single click, and then choose the last point. Using the mouse right wheel button, you can just rotate it. Right, now double click here and then click here, click here, click here, right mouse right button, and then click double click here. Last one, single click, single click, single click, double click. Wall panels have been applied. Go to load, go to wind wizard, worst case data, basic wind speed of 50. Next, 5 of the phase distance. Finish, give the load cases 90, 180, 270. Okay. Seismic wind wizard IS 1893 2016 we use. Ignore below the plinth level. Zone is zone 3. Importance factor 1 for residential. Model response spectrum analysis. Moment frame system. And then moment frame systems. Consideration of the dead load and the live load. Generating a load combination due to seismic load. Taking limited combinations. Taking the overall load combinations. Designing the model. Now we have designed the model successfully. Now we'll just check the ratio and wherever it is passing. So this ratio is 1.334 and 1.729. So we'll just increase the sizes of these particular columns here. So these columns we have, and we are doing this. Let's do this as 350 and then check whether what we are achieving here. And here also, as you can see, these columns also, let's do this as all these columns 1 2 3 4, again 1 2 3 and 4. Let's do this section. We'll find the section from here. (315 to 250), and then design selection static. Design selection static. Check the status. So now the columns which are not passing, as you can see, this 0.975, and let's check the reinforcement. By the way, design member static, and if we check the reinforcement here, okay, reinforcement is good. So let's increase the reinforcement. Maybe in that this concrete only it will pass. So we'll go to the design and then the design settings, and in the design settings let's increase this to, let's say, 20, and then check whether we have better results or not. And then we'll go to design all static, and then we'll check whether in the 20 it's passing or not. So we have better results now, but we might have to increase some of the dimensions of this particular line of the columns. Let's increase this and increase this to, let's say, 375, and then right click and then design all design selection static. So it's still failing by some ratio. So let's check why it is failing. Design member static, and we'll get to know the reason behind the failure. So it's actually failing in the longitudinal bar limit checks, clear spacing limit checks. So if we increase the particular size, then it might be sufficient for that. If we go for 375, if we go for 425 into 250, or else we'll next design selection static. Now it's passing. So we'll just once go to this review option, and ratio will check whether the members are economical or not. So there this yellow and this deep yellow, they're economical. The ratio lies between 0.6 and 0.8. So we'll just check the reinforcement which we are getting here, design member static, whether this is practically feasible or not. We also have to check that 60 16 is quite feasible. Here some members are still showing red. Let's check them also. Design member static, and sometimes it happens that it shows okay 60 20. This is also quite feasible. So the design is feasible. Now you can give it for reviewing. So it is to be noted that we have not inserted some secondary beams, and we have also not made the model as per the drawing also. But this is what a structural engineer like what I do to get an idea of what are the loads which are acting, so that I can make up the mind what are the sizes to provide. Before giving the final drawing, I'll definitely make you have to definitely make the structure as per the particular plan, and then give the drawing. But this is for the initial checking, that like this is the when you get an essay, you give a fast read to just to check out what the content is all about. So this is the fast step which a structural engineer can do. Like as I recommend that you can do this for checking what are the loads acting, what are the approximate sizes of the members which we'll get, so that you can get an idea of that particular project. So now we'll generate the drawings so that we can analyze the results, uh, column schedule, and then you can just click on all this particular columns, and you can save this in a particular file which I want. I'll give this a location in which I want to save the particular file. Let me go to my name of that particular client here, and THD results. I've already made that folder. Concrete column schedule. Yeah, this is name is good. Concrete column schedule, and just remove THD3, and then OK, save, and then click on OK. And then you can also visualize the results here. The concrete column schedule, it will automatically open in your CAD software, and you can visualize that all the details, floor by floor details, are mentioned in this particular column schedule, which you can check, and you can analyze it. So I'll just close this for now. So next you can find that there are some names: CRC D2, CRC D3. So these are the names which we have. So how to get these names? For getting those names, we'll go to home, and we'll just go to structure, we'll go to the base level, and here if we just go to draw and get the general arrangement, you will get the names of the columns. So here I'll just name this. I'll just take the name of the file here, or location of the file rather, and copy this, and then when I open the THD, and here I can paste it, so that you can have the okay. Here let me give this as column. This will be column layout, where I can get the names of the columns which I am giving, column layout, and then click on OK. And after the column layout, as you can see, this we have the names of the columns as C10, CRCD3. So this will be helpful for us. And then the next thing which we want is the beam schedule for the plinth level. We'll go to the plinth level. So first of all, let's give the beam layout. So for the beam layout, click on the general arrangement, and here we'll just click here, and here I'll give plinth beam layout, plinth beam layout, and here, and click on OK, and I'll also show you the file which is generated. So this is the plinth beam layout which we have generated here, and then just close this file, And then we also want the details of the plane beam, so the beam schedule for the plane beam. So this will name as your, just Ctrl V, this will name as plinth beam schedule. It contains the details of the plane beam. Save this, okay, and you can check out that the details of the top reinforcement and the bottom reinforcement, as you can see, 3020 4020 bottom and top, depth, and the details. CRC D3 will find in the layout, and the details you will find here in the schedule. So the plane beam schedule has been done, and after that we'll go for the first floor. Now in the first floor we'll do the same thing. This is the uh, just change this file. So this is not a plane beam, this is roof beam. You can see, since all the floors are similar above this, so this will be roof beam layout. And save this file, and click on OK. And then this is the roof beam layout, and after the roof beam layout we'll have the particular roof beam schedule as well. So this will be roof beam schedule. So roof beam schedule, schedule, this is my roof beam schedule which I will be having. And here also you'll have the details of the roof beams. So these are the details which you need. Slab will design manually, so we don't need that. And this is the results which we have obtained in the Tekla Structural Designer. If you want, you can also analyze and check the various things. You can find out the shear force and bending moment diagrams from here. This particular view, you can just go to this results view. You can have this results view here, and you can just check. If you just turn on the results, you can check the axial force. Just turn on the forces, you'll find the values also. You can find out the shear forces, and this shear force diagram, and then the bending moment diagrams. You can find out. You can go click and click on any particular member, and then you can go to the open. You can have this open load analysis view, and in this you can find the forces properly. And you just close this, and let's select a particular beam here, and then it will be better. Just go to scene content and slab items, just close this and click on a beam and right click, and then open load analysis view. You can find the bending moment, shear force, and also the influence line diagram here. So like this you can have the particular results, and as well as you can have the reactions also. If you just find the reactions here, turn on the results and have the various reactions, as well as the deflections also. If you want, you can find the values of the deflection as well here, and you can animate your deflections as well. So these are the results which we can obtain in this particular software. So hope this video was useful for you. Stay tuned to our channel to subscribe. Bye bye, keep learning.